Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 12.3, multiplying and dividing rational expressions, day 2. Yesterday we talked about how to multiply rational expressions. Today we are going to talk about how to divide rational expressions. The best part about it is there's only one extra step. So what I want you to do first is to go ahead and do the review of chapter 12 on your own. Try examples 1 and 2 quickly. See how you can do. So go ahead and pause the video, give it a shot, and when you come back we will have the answers for you. So go ahead and give it a shot. Here are the answers to your problems. Example 1 is x over 3. What we did is we took out the GCF of the numerator. The GCF was an x. It left me with x times x plus 3. Then we took out the GCF of the denominator. I took out a 3. It left me with 3 times x plus 3. I can go ahead and cancel both those x plus 3's, leave me with x over 3. In example 2, there was no factoring for me to be able to do, so what I started doing was simplifying. I canceled the 4 and the 16, turning the 16 into a 4. I canceled the 25 and the 10, turning the 25 into 5, the 10 into 2. At that point, I went ahead and I rewrote what I had left just so that I could look at it a little easier. So I was left with 5x to the third over 8x squared. At that point, what I did is I canceled 2 of the x's in the numerator with the 2 x's in the denominator, leaving me with 5x over 8. All right. So today what we're going to do is we're going to go ahead and divide. There's only one extra step, and it is actually kind of easy. So what we're going to do to start with is everything's exactly the same. You're still going to try to factor as far as you can. Then you want to simplify. But before you can cancel things out, what we need to do is we need to get rid of the division sign. If you remember from earlier this year, we were talking about dividing fractions. What we actually do is we keep, change, flip. So I actually need to take the reciprocal of the second fraction. So the first thing I'm going to do is I'm going to check all 4 of my pieces. 18x, can I factor it? Well, 18x cannot be factored. Then I'm going to look at my 4x squared. That cannot be factored. My 16x cannot be factored. And my 5 cannot be factored. Now, the fact that I have everything as factored as I possibly can, what I'm going to do is keep the first fraction the same, 18x over 4x squared. I'm going to change the division sign to multiplication, and I'm going to flip my second fraction. So keep the first fraction, change the sign to multiplication, and flip the second fraction. At this point, what I can do is I can start simplifying things, okay? The first thing that I want to simplify is the 18 with either the 4 or the 16. It doesn't really matter at this point. So if I cancel out the 18 and the 4, they're both divisible by 2, turning the 18 into a 9 and the 4 into a 2. Is there anything else that I can cancel? I can cancel the x that is with the 9 at this point with the x that's with the 16. So those are now gone. What that leaves me is 9 times 5, which is 45 in my numerator, over 2x squared times 16, which would be 32x squared. And at that point, I will be done because 45 and 32 cannot be simplified. Okay? On to B. Again, in B, I'm going to look for anything that can be factored. X minus 2 cannot be factored. I have that in both the numerators. XY cannot be factored, and Y cannot be factored. So at this point, I'm going to keep, change, flip. X minus 2 over XY. Keep the first fraction. Change the sign to multiplication. Flip the second fraction. Now I'm looking for anything that I can cancel. Well, x minus 2 can cancel with the x minus 2, and the y can cancel with the y. Here is a common mistake that happens with a lot of students. I've canceled everything in my numerator. I only have an x left in my denominator. A lot of students will just tell me that the answer is x. They'll just put down x. That is not true. X is still in the denominator. I need something in my numerator. In this case, it will be 1. Anytime I cancel everything out of the numerator, my numerator turns to 1. All right? On to C. This is the first time that I've actually had to factor. So I'm going to take this piece by piece. I'm going to factor it as far as I possibly can, and then I'll worry about what to do next. So I'm going to look at the 5x plus 10 first. 5x plus 10 can be factored using the GCF. The GCF of 5x and 10 is 5. 5x divided by 5 is x. 10 divided by 5 is 2. Over The next piece I'm going to look at is the 2x minus 20 because my 5 times x plus 2 cannot be factored any further. So 2x minus 20, I can also take out a GCF of 2, leaving me with x minus 10 because 2x divided by 2 is x, negative 20 divided by 2 is negative 10. So I have my first fraction completely factored. I want to factor my second fraction now. So 7x plus 14 is what I'm looking at. I could take out a GCF of 7, leave me with x plus 2, over, take out a GCF of, 7 times x plus 2 cannot be factored any further. So I'm going to go ahead and look at 14x minus 20, which what I'm going to take out here is going to be a 2, leaving me with 7x minus 10. All right. Now all 4 of my pieces have been completely factored. Once I'm completely factored, that's when our new step happens, where I'm going to keep my first fraction, 5 times x plus 2 over 2 times x minus 10. I'm going to change my sign to multiplication, and I'm going to flip my second fraction. Once I have completed the keep, change, flip, now I can start canceling things out. What can be canceled? Well, x plus 2 can be canceled. This 2 can be canceled. There is nothing else that can be canceled at this point because 5 cannot be canceled with the 7. 7x minus 10 is not the same thing as x minus 10. Therefore, I am done at this point. I just need to write what is left. What is left in my numerator is 5 times 7x minus 10 over 7 times x minus 10. Notice I wrote the 7 first because it's just easier and more common for us to look at it that way. You could write it with the 7 behind if you really wanted to. It doesn't change the fact that it would be multiplication, but that's where we're going to end. Okay, on to D. D, I can do some factoring as well. I can take the factor tree of 10, 1 times 10, 2 times 5. The middle term is positive, meaning my larger numbers need to be positive. They're multiplying to a positive, so my smaller numbers will be positive. What group can add to 7? That would be the 2 and the 5. So I factor that into x plus 2 times x plus 5. And I am done factoring my top left piece. The bottom left piece, the x minus 6, cannot be factored, so I'm going to leave that as x minus 6. I'm going to still have it as division because I have not been completely done factoring yet. I'm looking at the x plus 5. I'm going to leave that. Cannot be factored. And the x squared minus 36 can be factored into x plus 6, x minus 6. Hopefully you can see that. If any part of that cut off, the denominator on the right, the x squared minus 36, turned into, let me write it over here for you, x plus 6, x minus 6. That's what it turned into. Okay. So now that I am fully factored, what I'm going to do is keep, change, flip. So I'm going to keep my first fraction, x plus 2 times x plus 5 over x minus 6. I'm going to change my division to multiplication, and I'm going to make my second fraction. I'm going to flip it. So x plus 6 times x minus 6 over x plus 5. So I kept my first fraction, I changed my division to multiplication, and I flipped my second fraction. At this point, I can start canceling. So the x plus 5s go away, the x minus 6s go away, and I'm only left with the numerator. It'll be x plus 2 times x plus 6. And I will be done. On to E. E, I'm looking at all monomials. I don't have addition or subtraction. As soon as I see that it's all monomials, I know that nothing will be able to be factored. So I'm going to just make this 7x to the 4th over 1. Nothing can be factored, so I can go ahead and do my keep, change, flip right away. Keep my first fraction, change my sign to multiplication, flip my second fraction. I'm going to look for things that can cancel right away. Well, the 14 and the 7 can cancel, making the 14 a 2. I have 2 x's in my numerator, 4 x's in my denominator, so the 2 x's are completely gone. The 4 turns into a 2. So I have 2 times 1 in my numerator, just 2, over 5 times x to the second, will just be 5x to the second. On to F. I have one piece that can be factored. It is my top left corner, 4x plus 16. I can take out a GCF of 4, leave me with x plus 4. Over the 5x. I'm going to keep it going the same way. You could do your keep, change, flip here, where I change my division to multiplication and I flip my second fraction, but I'm not going to do that just to keep it consistent with the rest of the video. So I'm going to keep my second fraction. There's nothing over there that can be factored. At this point, I can do my keep, change, flip, keep my first fraction, change my division to multiplication, and flip my second fraction. I can cancel my x plus 4s. I can cancel my 15 with my 5, making my 15 a 3. I can take one of the x's away from my numerator with the x that's in my denominator, leaving me with 4 times 3, which is 12, x squared, and I am done. So that is the end of our lesson. Remember, the most important pieces here. You always want to factor as far as you possibly can with all 4 pieces of your 2 fractions. Once you have it fully factored, what you're going to do is you are going to use keep, change, flip to multiply by the reciprocal. So I'm going to keep my first fraction the way it looks. I'm going to change my division to multiplication, and I'm going to flip my second fraction. Once that is done, then I can go ahead and start simplifying, start crossing things out. If you have any questions over this video, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.